Hi everyone, and welcome to today's lesson on balancing equations. So this links as well to conservation of mass, and it's really important in the GCSE chemistry course, and it's vitally important that you understand it. So if you are writing this down, please do write down the title, which is balancing equations. You have some key words here as well. If you'd like to write those down, you're more than welcome. And you've got the learning objectives at the top. Okay, if you're not writing this down, okay, and you don't have access to a pad or paper, that's absolutely fine. You can take part just by listening and doing the activities either in your head or out loud. So if you are writing this down, it's balancing equations. You can write down the keywords, and there is something for you to think about, just to start you off and to lead you into today's lesson. So have a look at this. Okay, so this is actually calcium carbonate. Yeah, calcium carbonate. I want you to have a think about how many elements are there and how many atoms are there. Okay, there are two different questions, and it's really important that you understand the difference between these key terms. How many elements are there and how many atoms are there? I might help you by saying how many different elements are there. All right, so have a think, please, and be ready with your answer. Let's break this down a little bit. Okay, so let's get into the session by breaking down this question. So again, we've got calcium carbonate here, and these were your two questions to think about. I've kind of put a visual on the screen as well, just to help those visual learners and for you to see what's really going on. So this is calcium carbonate. I have a calcium atom, I have a carbon atom, yeah, because calcium, carbon, and I have 3 oxygen atoms. If you do have a periodic table, it might help. It's not obligatory, so you don't have to have a periodic table for this session, but it might help when it comes to kind of getting used to these elements. So this is what I've got here, okay? Again, I've got calcium carbonates as kind of a visual representation of this formula. So how many elements are there? Let's break it down. There are 3. There's calcium, there's carbon, and there's oxygen. Okay, they're the 3 different elements. How many atoms are there? There are 5. Okay, so there are 5 different atoms, 1 calcium, 1 carbon, and 3 oxygen. Again, it might seem a little bit easy for some of you, and for some of you it might be a little bit difficult, but it's just to get you thinking about what all this actually means. And it's actually really important that you understand it before we start balancing equations. All right. So very quickly, I'm going to talk about what is the point of balancing. What is the point? All right, so say if you had this word equation. So in chemistry, we call this a word equation. Hydrogen plus oxygen gives water. It has to be an arrow, okay? It's not an equal sign. In maths, obviously, you have equals, and it's because 2 plus 2 equals 4. It's exactly the same. But here, it's quite obvious that hydrogen plus oxygen does not equal water. It's not exactly the same. They're actually quite different. Yeah? Oxygen is obviously a gas, we need it to breathe in, and water is a liquid. So they're different things, but this is actually saying that hydrogen plus oxygen, which are the reactants, they're on the left-hand side of the equation, they make water in a reaction. So this is kind of what's happening in reaction. You might be looking at this GIF, you might be a little bit preoccupied with this GIF at the moment, and that is because actually you think, well, that's not relevant at all. Actually, it is. What is happening is we are reacting hydrogen and oxygen, okay? So what we're doing there is hydrogen in the balloon. Usually there's helium, isn't there, in balloons, but in this balloon there's hydrogen. That's why it's so explosive, it's very reactive. And we're reacting it with oxygen. We're giving it a little bit of a kickstart. We're kickstarting the reaction. They're giving it a bit of activation energy with that flame. So this is actually reacting oxygen with hydrogen, and we're getting water. You probably won't see lots of droplets of water because if the reaction is so explosive, it evaporates straight away. But this is actually showing what's happening in the reaction. You might be familiar with this kind of reaction. Now, this is a symbol equation, okay? And it's showing the elements or compounds involved. So I can say, right, okay, so I've got the element hydrogen. Yeah, it hangs around in 2s, it's diatomic. It's reacting with the element oxygen, again, diatomic, and it makes water. Okay, they're the symbols. That makes sense. This, however, is even better. Okay, now you'll notice that the elements have stayed the same. I've got two hydrogen atoms, two oxygen atoms that make water. And again, I have to have them as diatomic. I have to have H2 and O2. That can't change. We'll come into that a little bit more later. If I'm losing you, don't worry. We'll keep going over this. And it represents what actually happens in the reaction. Okay, it follows the law of conservation of mass. Right, which means mass cannot be created or destroyed. It's a fancy way of saying that everything on this side of the equation, okay, all of the reactants must equal all of the products, yeah? And it follows the law of conservation of mass. I cannot have atoms that just disappear in my reaction. And similarly, I can't have atoms that just appear. So if you look at this equation, okay, look at my mouse for me. If you look at this equation, it's saying I've got two hydrogen atoms, okay? They're reacting with two oxygen atoms. And what I get at the end is two hydrogen atoms, which is what I started with, so that's fine, but I only get one oxygen atom. That doesn't make sense. We've had one oxygen atom that's completely disappeared in the reaction, and that doesn't make sense. It doesn't follow the law of conservation of mass. Okay, it's a law in which everything must follow. You might have heard conservation of energy in physics. It's very similar. Energy cannot be created or destroyed. All right. So that's what we're looking at today. Okay, we're looking at balancing, and the reason for it is to follow the law of the conservation of mass. Also, the ratios. Okay, so these large kind of multipliers at the beginning, they're really important when it comes to calculations later on in chemistry. So when you're doing moles, when you're doing reacting masses, maybe when you're doing percentage atom economy, if you're a separate scientist, these are vitally important as well. So it's really important that you understand. Right, to get you started, what I would like you to do, if you have got a piece of paper, this is where it's going to come in really handy. Of course, you can just do this verbally. If you're watching this on your phone, you can have a look at these different substances or these different compounds, and then you can just do this verbally. I've started it off for you, so I want you to get into the habit of identifying the atoms, okay, and identifying the elements and how many of each atom there are. So I've given you a starter by saying that there is in this carbon dioxide, this is the substance, don't worry too much if you don't know how to say it, but this is carbon dioxide. There is one carbon atom and there is two oxygen atoms. Okay, and I want you to do the same thing, please, for each of the substances underneath. You might be thinking, oh, this is easy, but actually it's really important that you understand what's going on with the harder compounds at the bottom, okay, because there are brackets. Think about what brackets mean in maths is all I'm going to say. What I would like you to do now is I'd like you to pause this video and have a go at this activity. Okay, so if you haven't done that, please make sure you pause the video now because I'm going to go through the answers. All right, so have a look at my answers. I'm not going to go through all of them. I will say, don't worry if you spelled sulfur differently, okay, there's a couple of different spellings. I am going to quickly go through these last two, okay, so hopefully you can see that there is one magnesium atom and I've got OH, so I've got an oxygen hydrogen, but that's in a bracket and I have two of all of that, all right, so this two next to the bracket means I've got two of all of that. So I have two oxygen atoms and two hydrogen atoms. Obviously in maths, you're thinking, okay, I'm just going to multiply however many is inside by the number outside the bracket, and you can do that as well. So for example here, I'm saying I've got two lots of NO3, which means I can just multiply. So I've got 6 oxygens, 3 times 2, and I've got 2 nitrogens, 1 times 2, okay? If you didn't get any, if you got a couple of those wrong, I would really strongly suggest that you go back and kind of try and understand it, correct it and have another go because it's really important before we move on. Okay, let's get to the kind of juicy bit, the balancing equations bit. Let's have a look at what's on the screen. So you have hydrogen, you have oxygen, and it's making water. Now that is generally what's happening in the reaction. Okay, so you have hydrogen and oxygen, and it makes water. That is true. This is not balanced. Have a look. I have 2 atoms of hydrogen. I have 2 atoms of oxygen, and I've got water over here, which is 2 atoms of hydrogen and 1 atom of oxygen. So something's not right. Okay, it's not balanced. Remember, everything on this side of the equation must equal everything on this side of the equation. So let's look at this visually, all right? Let's look at what's going on. So this is just a visual representation of the symbol equation above, all right? 2 atoms of hydrogen, 2 atoms of oxygen, and this is an atom of water, yes? 2 of hydrogen and 1 of oxygen. Now, what I can do is I can put big numbers, I can put multipliers or big numbers in front. So I could put a big 2 or a big 3 or a big 4. I cannot change these small numbers, the subscript numbers we call them. Okay, I cannot change it because it makes it something completely different. You might think, oh, you know what? I'm just going to put a little 2 here. Look at my mouse. I'm going to put a little 2 here. Yeah, then it's balanced. That is wrong. I cannot change the small numbers. And that's because in chemistry, if I change the small numbers, the subscript numbers, it completely changes what it is. All right. For example, if I did do that, if I said H2O2 with a little 2 there, that's not water anymore. That's not water. I've actually made hydrogen peroxide. I've made bleach. And that's just not true. Yeah, hydrogen plus oxygen doesn't make bleach in this reaction. So I cannot change the small numbers. It completely changes what it is. I know that's quite strange to think, but if you think, oh, I'm just going to play around with the small numbers, what if I was to change this 2 to a 3? Surely I can do that. You cannot do that in chemistry, okay? Because actually it changes again what it is. So if I change this to a 3, it'd be ozone. It wouldn't be oxygen at all, a completely different substance. All right, so I can change the big numbers. Let's change the big number, okay? So let's think, right, I'm then going to put a 2 in front of this water, which means I have 2 water molecules. I'm then going to check it's balanced. All right, so on the right-hand side of the arrow, I now have 2 oxygen atoms. And on the left-hand side of the arrow, I have 2 oxygen atoms. Yes, oxygen's balanced. However, look what we've done. On the right-hand side of this arrow, I now have 4 atoms of hydrogen. 1, 2, 3, 4. Yeah, look here, I've got 4 atoms of hydrogen altogether. On the left-hand side of my arrow, I've got 2. It's not balanced. So what are you going to do? Are you going to change this small number, or are you going to put something at the front of the hydrogen? I'm hoping you're screaming at me. Put something at the front. I'm going to put a 2 at the front. Ding, this is now balanced. This is a balanced equation. Always go over it at the end. Never just think, oh yeah, I'm done, because you always want to double check. So you want to check, right, I've got 2 lots of H2. So I have 4 hydrogen atoms altogether. On this side, I have 4 hydrogen atoms. Excellent, that's balanced. Right, let's go back and check the oxygens. On this side, I have 2 oxygen atoms. And on this side, I have 2, because this number is saying that everything that comes after it is multiplied by 2. Okay, so I have 2 oxygen atoms. This is now a balanced symbol equation. Let's have another go, and then we'll do lots and lots of practice so you'll understand it. So just to go over, this small number is the subscript. It tells us the number of atoms. Yeah, like for example, there are 2. And this big number, the multiplier, it tells us the number of molecules there are altogether. So there are 2 waters. If you want to write any of this down, you're more than welcome to. I'd suggest maybe that you stop this video and kind of write down these key points. Let's have another go then. If you want to pause the video at this point and you're thinking, right, yeah, I'm understanding this, I'm going to have a go myself, please do. Okay, but if you want to a little bit more explanation, a little bit more extra support, let's do it together. All right, so I have 1 potassium. Let's get my visual up. Okay, so I have 1 potassium atom here. I have 2 atoms of oxygen, okay, which are here, and it's giving me potassium oxide, which is K2O. I cannot change the small numbers because that changes what it is. And we have been told that we have a reaction of potassium with oxygen and it makes potassium oxide. So I cannot change the subscript numbers. What are you going to do? Well, firstly, you should think, right, I've got 2 potassiums on this side and I've got 1 potassium. I'm going to change that. I don't like that. Okay. You might also be thinking, well, I've got 2 oxygen atoms on this side and I've got 1 oxygen atom on this side. It doesn't matter what you start with. Okay, let's start with the oxygens. So what I'm going to do is I'm going to add another potassium oxide. I'm going to do that by putting a 2 in front of this. Okay, so I've got 2 potassium oxides. Let's double check. So now I'm happy when it comes to oxygen, because on this side I've got 2 oxygens, and on this side I've got 2 oxygens. Hopefully you can see this. Am I happy with my potassiums now? Oh, it doesn't look it. I've got 1 atom of potassium on the left-hand side, and I've got 4 atoms of potassium on the right-hand side. Look at the kind of purpley pink spheres, okay? So I've got 1 atom of potassium on the left, 4 on the right. What am I going to do? I'm going to put a big 4 in front, okay? Now, this looks balanced to me, but of course, let's check. So on the whole of the left-hand side, I've got 4 potassiums, and the whole of the right-hand side, I've got 4, because 2 times 2 is 4, okay? On the whole of the left-hand side, I have 2 oxygen atoms, and the whole of the right-hand side, I have 2 oxygen atoms. Again, remember this big number means all of that is multiplied by 2. Really well done if you did that without any help. I'm really impressed, okay? Right, so before I let you loose on loads of examples, let's have a quick game of balanced or unbalanced, all right? So all I want you to do, you have 5 examples on the screen. All I want you to do is I just want you to tell me if they are balanced or unbalanced. A little bit of a word of warning before I tell you to pause the video. Remember to look at everything on the left-hand side of that arrow, all of the reactants. All right, so all of the reactants, like how many hydrogens are there on all of this left-hand side? Looks like there are 2. Look at everything on the right-hand side and go, how many atoms of hydrogen have I got? Looks like 1. Is that balanced or is that unbalanced? That's all I'm going to say. I'm going to say, watch out for number 5. It's my only piece of advice. Please pause the video now, and I just want you to tell me if 1 to 5 are balanced or unbalanced. Off you go. Okay, so I'm going to go through the answers, so make sure you've had a go. If not, please quickly pause it and have a go now. Here are the answers. All right, so we've got unbalanced, balanced, unbalanced, unbalanced, and this one is really tricky. I'm impressed if anyone spotted that it was actually balanced. I'll quickly go through number 5 because this is really tough. Now remember, it's all of the reactants must equal all of the products. Okay, the numbers of atoms on the left must equal the number of atoms on the right because of the law of the conservation of mass. So let's start with hydrogen on the left. There's a hydrogen here. This is Cl, by the way. Sometimes that looks like an I, doesn't it? But that's Cl for chlorine. So there's a hydrogen here. And oh, look, there's a hydrogen there as well. So there are 2 hydrogen atoms on the left-hand side. And there are 2 hydrogen atoms on the whole of the right-hand side. So really well done if you spotted that. There's 1 chlorine atom on the left and 1 chlorine atom on the right. And there is 1 sodium on the left and there is 1 sodium on the right. And the same with oxygen as well. So actually that is perfectly balanced. Really well done if you did that. If you got any of them wrong, I'd suggest going back and working through your answers and just to make sure that you really understand. All right. So let's put this into practice. So what I'm going to suggest again is I'm going to suggest that you pause this video and have a go at balancing. Remember what I said in terms of you cannot change the small numbers, the subscript numbers, but you can change the big numbers in front. You can change the multipliers. And actually you can have a play around. So if you get it wrong, you know, say if I was to just straight away, say if I was to put a 4 in front of this lithium, I don't know why, I'm just going to put a 4. That's okay. You can have a play around. And then you can think, right, okay, I've got 4 lithiums. I'm just going to put a 4 in front of here, which means I've got 4 lithiums. And then let's have a look at the chlorines. So you can get creative, okay? I'm going to suggest then that you pause the video and have a go at these 4 examples for me. 4 examples. Okay, again, I'm going to go through the answers, so please make sure you've had a go. It's really important that you're engaging in this lesson and not just kind of listening and thinking, hopefully it'll, you know, all of this knowledge will kind of diffuse into your brain. Unfortunately, it doesn't work like that. Balancing equations is actually quite difficult, and a lot of people find it really tricky. And I don't blame you if you do find it tricky. So please make sure you're actively engaging and having a go at these examples. It really will help. So I'm just going to put the numbers in now in terms of the answers, okay? So really, really well done if you got that correct. You can see the kind of green numbers at the front, which give the correct answers. By the way, word of warning, if you put a 4 in front of lithium, a 2 in front of the chlorine, and a 4 in front of this, that's actually technically correct, right? Because you've just doubled all the numbers. So actually, if you're looking at this and think, well, I've doubled all my numbers, that's actually okay. Yeah, because it's technically scientifically correct. Yeah, it follows the law of the conservation of mass. These are the simplest numbers, okay? So these are the simplest ratios. What I'll do is I'll give you an opportunity to kind of go through, make sure again that you tick them correct, or if you cross them if you got them wrong, and work through the ones that you got incorrect again. Really impressed if you're following so far and you're starting to get these right. That's fantastic. Okay, I'm going to leave you now with just some extra practice if you want. Okay, so the final learning objective is to practice a range of examples in order to master balancing chemical equations. So I think now that you've got to grips with it, maybe you understand the principles of balancing equations, but I'm going to leave you with some optional extra practice just to really make sure you master this. So if you want, what I'm going to say is I'm going to suggest that you can pause the video now and have a go at these 6. So these are the final 6 sort of practice problems, okay? So pause the video. Again, it's a really good idea, and I suggest having a piece of paper so that you can write it, because this is really difficult, and I think a lot of people would struggle to do this just from looking at it and in your mind. It's much better to write it down. The ones at the bottom, guys, are tricky. They are very difficult, so really well done. And I'd suggest only maybe if you're taking separate science. If you're taking separate science, then have a go at the bottom couple. If you're just doing combined science or double award, just have a go at the top. Yeah, just have a go at the top, 1 or 2 maybe. All right. So pause the video before, okay, and here are the answers. So I'm not going to go through them, but again, this is just for those that really want to master this. Here are the answers, and you can see that I've put the answers in red, so you can always, again, pause the video and make sure you got them correct. I'm going to also leave you with a different option. If you're struggling a little bit and you're looking at these and you're thinking, oh my goodness, that's actually way too tricky for me, that's okay, yeah, that's okay. So for those that kind of really want to master this, maybe you're taking separate science, I suggest having a go at these practice problems. And I'm going to leave you with this option as well. So I'm going to say Google PhET simulation balancing equations. This is a fantastic little website. I'm sure you might have come across it in lessons, or your teacher has shown you it before. And what I will do is I will actually show you what I mean. So if you go into Google, and if you go into PhET simulation, okay, balancing equations, so it comes up for me. We're going to say balancing equations, PhET simulation balancing equations. I'm going to click on this first link. You can see I've already clicked on it. And what you can do is completely safe, okay? And it's free to use, which is amazing. It's a fantastic resource. You can click download or play. So I'm just going to click play. Either one takes you to the same page. And if it doesn't take too long, I'm just going to kind of show you what it looks like. You've got an introduction to the game. Now, the game is really good fun. So once you've mastered it, I'd suggest the game. But for now, let's just have an introduction. And look at some of this that's happening. So right straight away, you can see we've got an equation at the bottom. Nitrogen plus hydrogen gives actually ammonia. This is ammonia, NH3. What I might do is I might add this tool. It might help. Okay, so this tool might help in terms of seeing what's going on. If it's too much, I'm just going to click none. And you can have a play around, guys. So what you can do is I'm going to add a nitrogen, I'm going to add a hydrogen, and I'm going to add an ammonia. All right, and if you use this kind of these colours to help you, I've got 2 blues on this side and I've got 1 blue on this side. So let's have a play around. Right, I'm going to add another ammonia. Essentially, it's just more of a visual aid. Okay, and whenever you balance it, it comes up with correct. This is balanced. So if you're struggling a little bit, and maybe, like I say, you're more of a visual learner, I would suggest Googling PhET simulation balancing equations and having a play around with that. Okay, well, thank you very much for taking part in this lesson. I hope you've understood everything, and I'll see you again soon.